Hello and welcome to this part 3 of So You Think You Can Link. In this session, we'll be looking at a few methods, link methods that are either not used or then people don't know they exist, that's in the case of intersect and accept. Where versus any versus count, just to clear up some differences, nuances there. So looking at some of the underlying implementation, if you will, of some of these methods, so you get a better sense of when to use which ones. And then we'll be looking at using LINQ with the file system. I think it's a lot of people don't seem to realize that because LINQ with to objects works with any collection or enumerable, that you can actually use LINQ to scan the file system, group files, order them, find out which files was last accessed, and various other information that's available in files, but using them through LINQ, so you can sort of use query style capabilities such as groupings and orders and stuff like that. And then we'll be looking at implementing our own merge function. In this function, we'll be taking in two sequences, and then we'll be merging them within this method such that the first element of sequence 1 is merged with the first element of sequence 2, and so on, and the merged result is returned. After that, we'll be looking at, so we'll have some demos, and then we'll be looking at deferred execution. Deferred execution is actually a very important part of LINQ and is the sort of precursor to LINQ Streaming. And LINQ Streaming is, I think, a very important part of LINQ itself, and it of course is made use of or made possible because of deferred execution, and deferred execution is made possible because of the iterator blocks that we looked at in the previous previous session. We'll be looking at query reuse, and then LINQ Streaming, as I said earlier, and then HOTS for higher order functions. HOTS, I'm just using this as a play on words. HOTS stands for higher order thinking skills, which I guess the education system uses quite a bit, or at least attempts to use it, essentially teaching us how to think analytically and synthesize the information that we hear or get from books and other places. Higher order functions are, as opposed to first order functions, are functions that take in other functions as parameters. So it does involve an additional layer of thinking because of the abstraction, wherein you can design a function that takes in other functions and then make use of those other functions inside of your code. Now LINQ is using this all over the place. I mean, when you look at a where method, it takes in a lambda, which is nothing but a function. And to be able to think about designing your methods that are higher order functions is sort of the key part of this session, this and streaming. So let's get back to our previous slide, and let's get to accept and intersect. The accept and intersect come from set mathematics, set algebra, where intersect implies where you have two sets. The intersect is where you have the common parts, and the accept is the not common parts. In LINQ and in databases, you have accept and intersect as methods. And so in LINQ, you would say, sequence 1 dot intersect sequence 2. And what will give you back is the intersect between the sequence 1 and sequence 2. And accept will give you the opposite of that. That is all the stuff that's not common between the two. And no duplicates will be returned. So that's accept and intersect. I think their implementation is iterative, unlike in databases where it's a set-based operation. It comes back pretty instantaneously, versus with LINQ to objects, it's an iterative process. So it's an n-squared complexity. Where versus any. Let's just look at code in this scenario. It's probably best to look at code. So I'm going to switch to Visual Studio. And here what you're going to see is, I'm going to use the pre-existing so first names dot where. Now the where takes in a predicate, as we can see over here, and this predicate is a string bool string because we are operating with strings here. So string bool is the signature of this predicate, something that returns a bool. A predicate is something that returns a bool anyway, so we're dealing with a string, and it returns an enumerable of string. So it returns the collection or the sequence of items that match the predicate, match the criteria. Any, on the other hand, it also takes in a predicate that has the same signature, but the difference is it returns a bool, right? So it's not returning the set of items. It just returns a true and false to tell you if something, at least one item, matches the criteria of the predicate. So you use where, of course, when you want the result and you want to be able to iterate over this result, or use the resulting elements that make up the criteria. Whereas you use any just to see if any one, at least one, makes up or matches the criteria. So the any method, some people use count. So where they say something like count of this, whatever the result is greater than 0. Basically, we're trying to understand if there is any result. Does the element, in this case, does the sequence first names have a count? Does it have at least one element? Well, if this sequence has 1,000 items, count won't return until it iterates over all 1,000 items. To tell you it's 1,000 and then 1,000 is greater than 0 will return to be a true, which means it had to iterate over the 1,000 elements first. Any, on the other hand, will kind of short circuit. As soon as there is at least one item, this will return true. So you don't have to use count greater than 0. Of course, we have a predicate here. You can further enhance it by using the predicate overload. But any returns bool, and it has the ability to short circuit. So you don't have to, if you got 1,000,000 items in your collection, you want to see if the count is greater than 0 to see if there's anything, at least one item in there, any will return right away. Now, any versus count. The other thing is that the any method, sorry, the count method, will use the count property for those sequences that actually have a count property. So collections such as lists have a count property, and the count method, so not the any, but the count method in LINQ, its implementation will use the count property if the sequence implements is a implementer of iList, or I believe iCollection as well. So keep that in mind. Depending on the underlying sequence, count may not actually iterate over all the items. Any won't do that anyways, because any is just seeing if something matches, and as soon as something does match, it exits the loop, if you will, or the iteration, and returns a true. So keep those few things in mind here. Okay, so moving on to the merge function. Well, actually, the other item was the file system, so let's get to the file system piece. So LINQ to file system. So what I have here is a method here, create video file, that is essentially creating a bunch of random video files with random extensions. So the names are random and the extensions are random. So these are different kinds of video files here. And this method create video files is initializing a bunch of files, up to 200 files on my machine here in my videos special folder, so that we can now use it. So I've already done that part. Now the idea is that you have a bunch of files in this folder, and you want to operate on the collection of files here. So let's look at some of the ways, things we could do with LINQ. So as part of the base class library, we have this static class called path that has the method, directory that has a method called enumerate files. And this enumerate files takes in the path, takes in a search pattern, and then search options. So let's look at these few options here. So the search path I'm going to use is the video folder over here. The search pattern is typically something like star.txt or something of that nature. In our case, because we're dealing with these video files, it's not just a single extension, it's multiple extensions. So what we are really wanting to do is we're going to say what we'd like to be able to do is give me all the files that match any one of these extensions. So we can't do that with the default sort of API, if you will, that's available to us. We can't do something like WMV semicolon star dot mp4 and so on. That's not, unfortunately, that's not possible. So we're going to have to use the star dot star option. Let's give me all the files, and then we'll have to filter out these files ourselves. The third parameter is just a search option that allows you to define either it's all directories, that is all the current directory, and subdirectories are only the current directory. So we're just going to pick all, even though we know there's no subfolders here. This returns to us an enumerable of strings. So we're going to call this files. And now, once we have files, we want video files. So I'm going to have another variable. So video files is equal to from f in files where. So what you in SQL you'd say where something in this collection, right? So in this set. So you could use the intersect here as well as an as an option, but that might be a bit slow because each time for every file you're seeing if the extension is in the intersect here. The question is, how do we get the extension? So with LINQ you have the option to define sort of local variables, if you will. You say let, let's call this extension, is equal to in this case we'll say path dot get extension, and give it the file name. It'll give you back an extension that includes the period. So you'll get back something like this. Of course, it's not case sensitive. So it's going to, if the files were created with the mixed casing or all caps, then this extension won't match. But we look at, for now, the simpler scenario, which is the cases are the same, or we don't have to worry about the case for now. So what we could do here is we could say where what we want to try and get again is using this extension. Does the file names files extension match this extension, right? So what do you say where f dot contains, and we could do the extension here, right? So you could basically from the file name, does the file name contain this extension? But of course it will. So what you want to do is look at this guy. So how do we get to choose? Let's say we had just these two, not all of them here, because all the files actually they're all going to match here. So this, we want to be interested in the ones that are WMVs and MP4s. So what we're going to do here is we're going to use this guy, and we say, does this guy contain this extension here? So video extensions dot contains the extension that we have for this file, right? So that's how we can do that, and then we can select the file itself. So this will give us all the files that match, that are all WMVs and MP4s only, not, so we do have some files that have like the FLV, MP, MPEG, MOV, and OGG file extensions, but we're only interested in this case these two file extensions. So if you were to iterate over these video files, I'm just going to type out the file name. So in this case it'll be path.get file name from the item in this case, just so we can see it clearly in our console window here. Let me also make this app the startup application. Okay. Right, we missed a curly here. Okay. So as you can see here, we have a bunch of files, and they all are either a WV extension or an MP4 extension, but not anything else. So that sort of works. Now it's not case insensitive, so let's see how we can make this case insensitive if you really had to. So the contains here has an overload of an eye quality comparer, as you can see here. So the eye quality comparer, we can define our own eye quality comparer and make that case insensitive. So let's see if we can work that out. So I'm going to define another class here let's call this class case insensitive. So let's call it case insensitive equality comparer. And it implements inequality comparer. Okay, this inequality comparer of strings, since we're dealing with strings here. Okay, so when we implement this, we've got to implement these two methods. I'm just going to do this guy first. He's simpler. Now, whenever you do implement inequality comparer, be sure you understand, truly understand the purpose of get hash code and the purpose of equals. I'm not going to explain that here, but just make sure you do understand these two things. They're extremely important, and you can go totally wrong with this if you don't understand this. So here I'm just going to return to you, return obj.getHashCode. And in here, what I want to do is now, if I get an x and a y, I want to be able to sort of do this case insensitive compare. So I'm going to return string.compare x comma y, and here I'm going to use the string comparison dot ordinal ignore case option, and if this thing is 0, essentially it returns true. So if it's 0, then return that. If not, return. So but I'm doing a case insensitive comparison here, ordinal ignore case. So it's an ordinal comparison, which is the sort of the fastest way to compare, and it's case insensitive. So if this returns true, then these are equal no matter what their case is, what their casing is. So to go back here, I'm just going to make this all caps. Just one of them could be all caps, doesn't matter. And we run through the same thing. We didn't see the count here, but if you see any WMVs, we know that and the WMV, the file name, will have a lowercase extension. We know it's working. The case, oh, we didn't. Oh, so right now what you'll see is because we didn't include the equality comparer, we're seeing only MP4s. There are no WMVs in our result here, which is that would be expected. So now let's include the equality comparer. So we say new case insensitive equality comparer, and now when we run this again, we should see again WMVs. And in this case, they are lowercase WMVs, so which is what we expect. So just another way of showing you how you can use LINQ with the file system. And you can do other things in addition to this. You could say, okay, then now let's group these. So group F by extension into G. So we group F by extension into G. And what we can do here is we could say new, let's call this extension is equal to g.key, and then count is equal to g.count, right? So we have an anonymous type that has a property of extension that has the key, which is the extension, and then the count. Now we could say, if you wanted this property to be key instead of extension, then we could just ignore this part. As you remember from our previous session about anonymous types, I could just say g.key here. Now this is a count method, so I can't do the same here, but if this was a count property, I could also ignore this part and just leave it as count, g.count. But because it's a method, it won't work like that. And then over here what we have is we don't have item. This item is sort of a different type here. So item dot key will give us the extension, if you will, and then we could have the count here. So that's item dot count, and let's see what this will do. Basically, it will give us for all the files the different counts. So we have here for WMVs the 38 WMVs, and for MP4s there are 38, and we can include the other extensions. Let's just do that. Include all of the extensions here. So you can get a count of so this is the sort of the grouping value, the grouping counts. And they're evenly distributed here almost because of the fact that we are using the random number generator to, in our case, when I created these files, and the random number generator will by force be evenly distributed, because that's the whole sort of the telltale sign of a random number generator, is that it can evenly distribute its randomness. So anyway, so that takes care of our LINQ with files, with the file system option. Again, it's all just standard LINQ syntax. You could use method syntax as well here. You didn't have to use the query expression syntax, but just want to show you that. Okay, moving on to the merge method. So the merge method, what I want to do here is I want to define a method that takes in these two sequences and then merges them in such a way that we get back George Washington, John Adams, Thomas Jefferson, and so on. So let's define this method. So it's going to return a string, and it's going to be called merge, and it's going to take in this well, actually, you know what, let's up the ante a bit. Let's make this generic. So t result is the type. Actually, it's going to be an IEnumerable of t result, and this IEnumerable here is going to be of type t, which is a different type most likely. It could be. So this method will need to take in a t and a t result. So IEnumerable, let's call this sequence first. The next IEnumerable of t, let's call that sequence second. And now here, as I said, what we need to do is merge these two sequences and extract that. So this is not a nested loop, because for every one iteration of sequence 1, you want to go 1 into sequence 2 as well. So it's not like you can iterate over this, and it's not an n squared kind of operation. So it's an n operation. So the way you would do this, you would do something like using enumerator of t, whatever the t is. Again, remember, we are implementing this as a generic method, so we got to keep be careful of the fact that we are not strongly typing anything here, or making it a specific type. So this is enumerator 1, which is nothing but sequence first dot get enumerator, if you remember our previous session. And then enumerator 2 is nothing but sequence second dot get enumerator. So all I'm really doing here is I'm defining a type, and there's two variables, enumerator 1, and I'm initializing it, comma enumerator 2, and I'm initializing it. If you're not comfortable with this, you could do this. You could say using enumerator of t, enumerator 2, and so on. So either way is fine. It's probably a little more legible. So continuing on from here, we can do while enumerator 1 dot move next. So while you can move next on the first enumerator, and you can move next on the second enumerator, do something. Now, if this were not a generic method, then what you could do is you could do a yield return enumerator 1 dot current plus enumerator 2 dot current, right? But this is not obviously going to work in this case, because this method is a generic implementation. So you don't know what current is, what type it is. You can't add it or concatenate it with a string. That's not necessarily legal in all scenarios except for when it's a string. So this is not going to be allowed here, but that's kind of like what we want to do in this scenario, in this method here. So because we can't do this in this method here, what we could do is we could say, well, if you gave me a method in this method, then I could call that method of yours, and then you can return the type, the t result, whatever that is. So you can do the merging outside of this method here, and then give me back a result. So this makes this merge function now a higher order function, and the delegate would be, so we're going to define a method or a delegate here. So it's going to be a func because it returns something, and this func is going to take in a tt, so two t's, and it's going to return a t result. Let's call this parameter merge func. And so this two t's, because it's going to take in two, in our case, specific case, is going to be strings, but we don't know them to be strings. But nonetheless, we're going to have to pass in the current and the current. So that's the two t's. Remember the t, and whatever it is the t result is going to return here. So that func takes in two t's and returns a t result. So we can then just call that method here, func merge func numerator.current, comma numerator2.current. And as far as this method is concerned, the implementation is done. We are finished with this method. But just keep in mind here some of the complexities that may not be normal for most scenarios, as in we don't normally do this kind of thing. But that's why I thought this merge function would be interesting. And then the second part, that this function has become a higher order function because it takes in another method as a parameter. So we have to now, when we call this method, if we were to try and call this method, so let's call this full names is equal to merge, and let's look at the signature. Let's pass in first names. Let's pass in last names. And this third parameter here is this merge string t result. So we still don't know the t result here. I mean, we would be if we made this a string. Since we know this is a string, the compiler would actually figure that out here. I guess it hasn't, but this is actually an enumerable of string. So this is we need to call this enumerable of string. I think that it'll figure that out now. I guess it doesn't, but nonetheless, it's going to be a string. We know that in our scenario. So we have to pass in a method that has the signature. It takes in two strings and returns, in our case, a string. So we could implement it as a lambda in here. So we could say this is f name, l name goes to f name plus space plus l name, right? So that's the lambda version of this, and this works just fine. Now what if we wanted to you can test this out. Let me set this what are we doing here? LINQ merge. Let me set LINQ merge as the startup project. Okay. So the full names should include all of the names that are joined in here. So let me redo this. I don't like to use this version of the zoom in because it makes my mouse I can't really see it properly. I don't know what happens with the recording, but it's pretty difficult to use with all the flickering. Okay, there we go. So we have George Washington, John Adams, Thomas Jefferson, and so on. So it's doing what we wanted, or what we expected. But what if I wanted to do this? So this style of first name, last name merging is sort of the American style, the non-American style. American style is typically last name, comma, first name. So we would have to change this implementation here. The other way we could do it, the way I prefer to do it, if I need two ways to do the same thing, I'd define them as methods here. In this case, it returns a string. Let's call it British style full name. That takes in first name, last name, and its implementation is return first name plus space plus last name. Actually, in British style, this would not be first name and last name. This would be first name and surname. And then the American style. So let's call this American style. And here it would be last name, but it'll be last name plus comma plus first name. And now when I call this merge method here, I have the option to either send in this method, the British style, or the American style. Depending on which one I call, I get different behavior. So this method, being a higher order function that allows me to pass in another function as a parameter, is then allowing me to decide at runtime, typically, or also to decide which method to call, this one or this one. So I could have some sort of conditional statement that says, well, if this is the scenario, then send in the American style full name, otherwise send in the British style full name as the delegate to this method. It's effectively allowing me a sense of polymorphism, if you will, wherein I can get different behavior by passing in the different delegate based on some runtime condition. So I call this the poor man's polymorphism, because you don't have the overhead of thinking about the name of the class and the design of the classes and the descendants and all the stuff that goes in with defining class hierarchies or well-designed classes in their hierarchies. You get it very simply by just defining two methods that have different behavior. Defining a method that is a higher order function that takes in this delegate, and then at runtime you can decide whether you want to send in this delegate or you want to send in this delegate to get different behavior. So this is the first sort of introduction to the higher order function capability, or the way we want to start designing our systems, if you will, making use of higher order functions. Let's look at the next topic. Let me just move to the slide, make sure we're okay. So we've done the where versus any, we've done the link for the file system, we've done the merge, we've done the demo, and now we go on to deferred execution and query reuse, LINQ streaming, and as I said, higher order functions we're going to be doing throughout this session. So we are now going to be looking at deferred execution and LINQ streaming. For that, we have a different project. This project is the streaming and iterators project. Okay, it's a blank, clear slate. What I have in this project is I've got a president's class that looks like this. So the president has an ID, first name, last name, year, email, is alive, and implemented this toString method. For those of you who don't know, when you implement a toString method in your classes, the IDE or the debugger uses the toString to show you the values, if you will, of the instances when you hover over them in your debugger, when you're in debug mode. So it's a useful way to look at some of these disparate properties here. If you just implemented the toString to include all the information you wanted, only the information you actually are interested in your toString implementation, then the debugger just uses the toString, and so does the console or write line, for example, for that matter. It uses the toString method to show the results. So it saves you the trouble of having to do this over and over, at least in demos, but also in real code. The downside is that you have an implementation like this that goes into production code that is not necessarily used in production code. It could be, but it's not necessarily used in production code. So I'm not a big fan of this unless I need it in production as well. But it's nice to know when you're doing a debugging that you can do this for debugging purposes. Okay, so what we want to do is we have a text file here, and this text file is a comma delimited text file that has all of the presidents here in one president per line and comma delimited properties. And the president, what we want to do here in our project here is to read that file and then sort of instantiate a president for each one of those lines, and then have a collection of presidents. So let's first define the method itself. So this method is going to be returning to us an IEnumerable of president, and let's call this method get presidents. So maybe you want to send this method a file name. Let's where's the file that we wanted to read. And here we're going to have to use the file, or open a file and use it. So file stream is equal to new file stream, and the file stream, so some of the overloads we're going to use is this one. So the path, which is file name, and then file mode dot open, file access dot read, file share dot none. Okay, this is doesn't have to be so complicated, but I'm using this. There's simpler ways to do this. And then I could have a reader that is a new stream reader that takes in the file stream as a constructor parameter. And now the reader gives me a line. So reader.readLine gives me the line. And we know that the line is comma delimited, so we can have then fields is equal to line.split on the comma. Okay, so now we have the fields. And then I actually have the code that does the split here. This will have to be a yield return, because we're returning an enumerable of president, not a single president. So once we have the fields, we parse out the fields, indexing into the fields, and assign them to the properties. In some cases we have to convert them to ints or bools, and we have a president, and we yield return this president. Now let's look at using this thing. So first of all, we'll have presidents is equal to get presidents, giving it the file name. The file name in our case is presidents.txt. So it is in ///presidents.txt. And we get a bunch of presidents here. Now we can iterate over these presidents to make sure we are getting and here I can just type in item. We know that the to string will be used here, so it'll actually print out all of the properties that we're interested in this case. So let's make this project the startup project. Nope, something went wrong. Directory not found. So // it didn't find the directory. Let's make sure I didn't type anything wrong. I guess there's maybe I'm passing in the wrong path here. Right, there's the dot here. Okay. Okay, so we have our president. Now what's happened here is what's happened is that we didn't read this line properly, so we just read the first line. So we need to do while. Let me line is equal to null, while line equals reader dot read line is not equal to null. I need to do that. Okay. So that'll read lines till there's no more lines to read, and for every line it reads, it's gonna return that, and that should work the way we expect. So what we're seeing here is a bunch of let me see if I can improve the readability here. How's that? Okay. Width. Okay. That's better. Okay. So we've got all of our presidents here. All the ones that are in the file. All right. So the next thing is to show you some streaming, how streaming actually works. So let's say I had all presidents that are alive, that is from P in presidents. Actually, let me use the method syntax here, but I want to be able to put a breakpoint. So I want to say where P dot is alive, right? So I'm just going to do this as a Lambda statement block. So I can put a breakpoint here. Return P dot is alive. Okay. So I've got presidents that's iterating over the file. Then I've got another collection that is from based off of the presidents here that are those who are alive. And I want to print out, iterate over the ones that are alive and write them out to the console here. So I'm going to put a few breakpoints. I'm going to put a breakpoint here, breakpoint there, breakpoint there. And here I'm going to put a breakpoint here and here. Okay. I'm going to step through this code and see what is going on. So first off, it didn't stop here. It didn't stop there. It didn't stop here. It went straight in here. Okay, so that's the first thing to kind of understand. What's happening is these queries are deferred execution, and as a result, they don't actually execute until you iterate over something. In this case, we're iterating over the second query, not the first one. The first, we might not call this a query, but it's really a query. It's essentially select presidents. Okay. So when we come in the in, at that point it has to materialize the collection that makes up the is alive query here. That's the point it goes into the file for the first time. So it's now reading the first line in the file. It yield returns this president. So it returns this president. It's read only one line so far. It returns this one president. As soon as it reads the line, it returns the president. At this point, it then comes into validate if that president, the first one it's read in, is alive. And in this case, we know it's not. So it comes back, or goes into the method where it left off. So the yield return, this is like the iterator block. So the yield return is doing what it's doing, supposed to be doing, which is it re-enters this method, if you will, where it left off. So it left off in the yield return. It come back in here. It then gets the next line. It yield returns the next president. It goes back in here to check it. And so it's not come in here yet. It's still trying to get the alive one at a time, but only those that are alive in this case. So it's iterating the presidents, but it's not doing the alive as it's trying to materialize the alive. So this is being materialized, and it's trying to materialize the alive. Therefore, it's just waiting over here. It doesn't come to here to actually print out the one that is alive. So this is going to go a few times with the first few presidents we have in our text file are not alive. Let's see who this is. This is Lyndon Johnson. So we got a few more to go. Okay. Ford. Okay. So now what we have is this item, which is Jimmy Carter, and Jimmy Carter is alive. So that's the first time it's come into item here, and it's going to print out this item, in this case Jimmy Carter. So what you want to keep a track of here is that in this case we're reading from a file, so it's reading one line at a time. The way we've implemented this code is using the iterator block, the yield return, and so as it receives the one line from the file, it constructs an instance of a president and returns that president out to the president's collection. Then we have the is alive version of it, and so it's then materializing from the president's collection only those that are alive to construct this query or this sequence. And that's the sequence we're iterating over. So even though we're iterating over the second sequence, is having to materialize the first sequence that happens to have to read the file. And this is deferred execution and LINQ streaming simultaneously. So the deferred execution part is that it never executed precedence, it never executed alive until it came to the for each. It's only when it's tried to enumerate the alive that it actually executed the queries, in this case the alive query as well as the precedence query. But the streaming part is that the records are appearing, in this case precedents are appearing one line at a time. So it's reading only one line, it's not reading up the whole file into memory. It's got only one precedent, it's not accumulating a bunch of precedents before it returns from this method. It returns the precedent, the first precedent, as soon as it returns, reads the first line. So that's the key part to remember in the streaming aspect. And then as it returns the first precedent, it comes into alive, and if it works if the alive method, in this case criteria is true, it then comes into here. So streaming means it's going from the file to the first sequence to the second sequence to the for each in a streaming fashion. The same precedent that came out of the file, the first one, comes and goes into the where criteria, and if it succeeds, it comes into the console or write line. So that's why it's called streaming. So also deferred execution. So if we were to run, put a breakpoint here and remove all these breakpoints, you'll see we should then see our only those precedents that are currently alive, but it happened in a streaming fashion. So one of the advantages of streaming is that you're not having to accumulate a collection. If I had, this was like customers and I had like 1,000 customers, I didn't have to first build up the 1,000 customers into a collection and allocate memory for the 1,000 customers and wait for the period of time it took me to read the file and initialize the 1,000 customers and stuff them in a collection and then return that collection out of here. I could do that. I could have implemented this method in a slightly different fashion that did that and returned a 9-enumerable of precedent. That was nothing but a collection, if you will, not a sequence, but a collection of precedents. But then it was accumulating, allocating memory and waiting to read up all of the customers or whatever the type is here, and then return that from that method. So streaming is one line at a time, one thing at a time, and it goes through the whole endpoint here. So these could be in different layers of your system, your data layer, business layer, UI layer, and so on. And it would stream right through the layers, and eventually it would get the same one precedent that made up the criteria would be the one that came on here, but there was no real collection to deal with per se. Now we can do the same thing with databases. So I have here in this project, I'm going to go to the details of the project, but essentially there's a data layer, and in the data layer there's a data manager. In this case we have a precedence data manager. And if you look at this implementation, this is using ADO.NET Core, so you'll see all of the artifacts of ADO.NET Core. What we have is a method over here that returns to us a data reader using a store proc. So we have a store proc here that called get precedents, and that returns to us a data reader, which this method is using here. And when it gets a data reader, it reads the data reader. Now the data reader is a streaming data reader, meaning as it's receiving data from SQL Server in this case, it's going to be streaming the records as they appear over the pipe, over the TCP connection. So the streaming data reader again is doing the streaming in the sense it's not accumulating all the results before it starts to send you the results out. That's one of the sort of the benefits of a data reader is the data reaches you as soon as it's available. It's not waiting for, if you have 1 million records coming back, it's going to wait for the 1 million records to be materialized before it starts to stream the 1 million records. It starts to stream them as soon as the first one arrives. Here we're reading them one record at a time, and as we get the one record, we yield return an instance of a precedent, just like we were doing with the file system, or when we're reading from a file. So in this scenario, we have a streaming data reader that's yield returning, in this case, a instance of a precedent as soon as the one line is received, and returns a 9-enumerable of precedent. So it's not returning a data reader, but it's using the data reader under the hood. And let's use this now. So over here, I'm going to define a data facade, a new instance of a data facade, and then I'll have precedence is equal to data facade dot get precedence. I can comment this one out for now, and the same thing applies here now. So now remember that when you're working with ADU.NET, if you have a criteria like this, you might as well put this into your database. As in, you probably have a different stored procedure that has get precedence alive or get alive precedence or whatever it is, rather than trying to do this in the form of link to objects here. So, but I just want to show you the streaming ability and the deferred execution concept. So once again, I've got now a collection of precedents, except these precedents come from a database. That might take a few seconds for this to fire up, but let's do that. And also let's put in the breakpoint in here so we know when it reaches the first record. Okay, so now it's read the first record. Is yield returning a precedent? Is this precedent alive? No. So it won't come in here. It'll go back to read the next record and so on. So it's the same behavior. Two same behaviors. One is the fact that it's deferred execution, and second that is streaming. Streaming because as we get a record, we return the precedent in this case. We're not waiting to accumulate all the precedents. So eventually we'll have the net result that we were expecting, which is all of our precedents that are alive in the database that we have, and thus the precedents that are currently alive, at least the ones that are in our database. And so when would you use this streaming scenario? In from a database perspective, there's a few scenarios that are kind of most obvious to me. One is if all you're doing is extracting data from a database to stream it out as a JSON string or as an XML string, or if you're just blindly just producing HTML in a page to render a data in the form of a grid or some other UI pattern, at that point you might as well just take the data reader. You might as well implement it like this, where you're not accumulating collections. You're not accumulating the collection 2 or 3 times and iterating over your collection, your result set 2 or 3 times just to do your stuff. Meaning, if you went from a data reader to say entity framework, entity classes, to then some other classes, to then resource model and out as a JSON string, you're doing 2 things. You're first of all allocating a whole lot of memory for each of the items that you have in your collection, and you're iterating over that same collection. So if you have 1,000 records, you typically be iterating over your collection 3 times because you're going from layer to layer, and they're accumulating the same sort of collection, if you will, in different classes. And eventually, to produce the JSON string or the XML string, you're iterating it one more time. You could do this all in one shot, meaning as you're iterating over the one record, you're sending this instance out. You're only accumulating one precedent at a time, and you're iterating all the way to the point of producing JSON or XML or whatever the case may be. The iteration also happens just one time. So in one iteration and with one instance, you're achieving your end without having to do the accumulation and the reiterations, if you will, over the collections. So that's definitely a good place to use the notion of an enumerable that's coming off of a data reader or a file system, and you're using the LINQ streaming option or LINQ streaming capability to do that. It's not something you can use everywhere, but definitely in a lot of areas, especially in today's systems where you're constantly pushing out JSON or XML or some other form of data in the form of an API, and all they're really doing is once you've figured out what data to send back, you're sending it back. And there's not a whole lot of stuff going on in some of those systems where you're just publishing an API. If I was to iterate over this, if I was to call get precedence multiple times, it would make the queries multiple times. So there's something to be aware of. If I need to use this collection multiple times within the same sort of request response cycle, then I would make this a to list. So for example, over here, when I use it, I just do this as a to list, and then I'd use this precedence multiple times in my code here in the same request response cycle. That way I won't make multiple database calls. I'd just make a single database call. You can make this a read-only list as well if you wanted. So these are the options really I wanted to show you or talk about. Streaming and deferred execution and how they all kind of go together. In fact, the iterator block makes everything possible, and then deferred execution is sort of a feature that was then possible for us to us in LINQ with the help of the iterator block. And then streaming, of course, is the next step up from there. Now the other thing you could do is this is just more like a refactoring, if you will, nothing extra with regards to what we're trying to learn here. But one could say that you don't want to be doing the sort of file pieces, opening of the files and things over here. Maybe you want the caller to determine, do all of that stuff. So for testing purposes, you're not necessarily relying on a file, because you're sending in a file here. You're kind of forced to have a file physically available for your testing purposes. But you want to have another opportunity to decide what that thing really is. Is it a file or something else? So one option is to change this to be a I guess text reader, and here we could have this as a reader, and then we don't need this part here, and what we need, we don't even need this part here, so we just have a reader now. Okay, like that. And the reader can do its part, and the reader is a sort of the base class, if you will, of all the string readers and stream readers and so on. So we're just working with the base class type here. And when I call this method, then I would create an instance here. So I could do this as simply as file dot open text, giving it this file name, this file path. So that's one way to call this method here. This allows you for when you're doing testing, instead of actually working with a file, you could work with a new string reader, and the string reader takes in a string. It's also a descendant of a text reader, so it resolves to the same type, but it allows you to pass in a string here. So for testing purposes, you could pass in the string, and the string could be let's say all the data here that you have in the file. For now, if I just picked up the first line, you'd kind of get a sense of what I mean. So this is a string reader that returns is really a descendant of text reader, so it works even for testing purposes. Now the other option, or the other aspect of this thing, is what if the file we were getting was not a comma delimited file? So what if the file was a fixed length file? Now we have such a file here in our project. We have a fixed length file as well, and as you can see here, there's no commas here. It's just a fixed length file, and we want to be able to use one or the other option. So going back to the notion of a higher order function, what we need is a function. So it's a func that takes in a string, which is the line, and in our case it returns a precedent. Let's call this line parser, the name of the parameter. So I could essentially take this part here, and I could say yield return line parser, giving it the line as the parameter, the line that we have over here. And that's the sort of the end of this implementation, but we've kind of offloaded the heavy lifting to this method here that takes in a line that goes to, and I'm going to implement this as a Lambda statement block. And what you have here is, we can't yield return this because we're returning a singular precedent here, so it's not the method returns a single precedent, not a numerable, so it's just doing a return new. And that's how we would call this method within the at the time of calling the method itself, allowing us to then change the file name. So if we change this file name to the one that has the fixed length file, So that's the fixed length file. Then the implementation here won't even actually be doing the split, so you can change the implementation out to something completely different, and I already have that implemented, luckily. And this is using the fixed length capability, so we return the same thing. So again, it allows you to have different behavior or reuse this method in this case by changing out by injecting your logic here. So one of the ways to look at higher order functions is that they allow you to inject custom code, if you will. So this is custom code at certain points in their operation here. So in our case, we are able to inject custom code that knows how to parse out, in this case, precedence from a fixed length text file versus a comma delimited text file, and we can decide which one to use when. And these could be full methods. They don't have to be Lambda statement blocks, or they can be Lambda statement blocks, whatever you prefer. The idea is that this method here has now been converted into a higher order function that allows you to inject some custom code within the core of this method itself, or think of it as poor man's polymorphism, which allows you to change behavior of your method at runtime or at some other compile time, depending on how you want to use it. So that brings us to the conclusion of part 3 of this LINQ. So you think you can LINQ series. I hope I have done a good job of explaining some of these concepts, and that you have learned something new. So until the next time, see you all. Bye-bye.